Good evening, dear all. In the previous video, we have seen how to charge a body and what are the properties that a charging body can have or charges can have. Now, in this video, we will take up the main heading as Coulomb's law, in which we will cover some points like formulating the law, then making variations in the available law itself, thinking of the possible numericals with those concepts, graphs of those concepts, and then defining Coulomb's law. Finally, we will end the video with the vector notation of the Coulomb's law and certain numericals based on the law. Now, beginning with the Coulomb's law, let us first state the law. According to the law, force between 2 point charges varies inversely as the square of the distance between the two charges. As you can see, we have considered two charges Q1 and Q2 at a distance r, placed in vacuum. So, according to the first part of the law, we can write the proportionality as F is inversely proportional to r square. Now, according to the second part of the law, force between these 2 point charges is directly proportional to the product of the two charges magnitude. Can be written as F directly proportional to Q1, Q2. Combining these two proportionalities, we have F is equal to K Q1 Q2 upon R square, with a modulus at Q1 and Q2 indicating that we are only interested in the magnitude right now of the charges, where K is a constant of proportionality. Now, the value of K is always positive and it is also arbitrary, given as 9 into 10 raised to 9 Newton meter square per Coulomb square, where Newton meter square per Coulomb square is the SI unit of K. Formula of K is given as 1 upon 4 pi epsilon naught, where epsilon naught is the electrical permittivity of free space. Now, what is this permittivity? Permittivity is the permission given by the medium to the charges such that they can exert force on each other, whether repulsion or for attraction. So, permittivity is the permission given by the medium to the charges. Its value is 8.854 into 10 raised to minus 12 Coulomb square per Newton meter square, where Coulomb square per Newton meter square is again the SI unit of the permittivity in free space epsilon naught. So, formulating the Coulomb's law, now let us talk about the variations of the law. Now, we have already written the formula of the forces between the two charges as F is equal to K, Q1, Q2 upon R square, where we kept both the charges in vacuum. Suppose we don't keep the charges in vacuum, then we write the formula as 1 upon 4 pi epsilon m Q1 Q2 upon R square. Instead of writing K as 1 upon 4 pi epsilon naught, we have written K dash is equal to 1 upon 4 pi epsilon m, where epsilon m is equal to epsilon r epsilon naught, and epsilon m is the permittivity in the medium other than air. Epsilon R is the relative permittivity, I am writing in short, permittivity of the medium, where medium also I have written in short. Epsilon naught, as already told, is the permittivity in short in a free space. So if I keep the two charges in some other medium, then I write K dash is equal to 1 by 4 pi epsilon m, where epsilon m is equal to epsilon r, epsilon naught. Epsilon m is permittivity in the given medium, epsilon r is its relative permittivity of the medium, and epsilon naught is a permittivity in the free space. Now, where is this epsilon r for air? For air, epsilon r is equal to approximately 1. That is the reason why we have not written epsilon r here. Otherwise, we would have written epsilon r here also, as the formula says. So, for air, substituting epsilon r as 1, we just write epsilon m is equal to epsilon naught. Okay. Now it is clear that if at all the medium is air, then the value of force is maximum. Why? Because F is inversely proportional to epsilon m. So, getting the knowledge of what is the force between the two charges when we place them in air and when we place them in vacuum, we move to a new section where you can think of and make your own numericals with variations available to you according to the formula. Let us consider about the first variation, that instead of air, there is another medium. Then what is the variation in the force? Is it going to be more compared to that of the air, or is it going to be less compared to that of another medium other than air? So this I have written the formula for force when we take air as the medium. Now we are writing another formula when we take some other medium other than air, choosing the same charges and the same medium. Now here we don't have epsilon r, here we have epsilon r. Let us take epsilon r as something around 6 approximately. And here we do not have that value of epsilon r itself. So, what do we get here as? F dash is equal to 1 upon 6, because epsilon r is 6. 1 upon 4 pi epsilon naught. I have taken the value out. Q1, Q2 upon r square. This portion is F. So I can write F dash is equal to 1 upon 6 F. So what is my answer? F dash is equal to F upon 6, or F is equal to 6 F dash. So like this, if at all they ask you to compare the forces between the two charges in a different medium and in air, you can just put the value of epsilon r and get the ratio as I showed you, or you can even say how many times is the new force compared to the old force, or how many times is the old force compared to the new force. All variations can be in your mind itself while studying. This is the first variation in which you have done the variation that you have changed the medium. Okay. Now we come again back to the formula. F is equal to K Q1 Q2 upon R square, where we can make the variation in the charges compared to the given charge. So let us make the variation that we have doubled the charge Q. So we got a new charge Q dash is equal to Q1. We have kept the charge Q2 as it is. So let us name it as Q2 itself. Okay, so we have in the new format Q dash as 2Q1 and Q double dash as Q2 itself. We didn't change Q2. We only doubled Q1. So this has become doubled. This is the same. Now let us substitute and find out the new variation. So F dash is equal to K. Our formula becomes Q dash, Q double dash upon R square, keeping K as same medium and keeping the distance R also as same. There is only variation in Q dash and Q double dash. Let us see the answer. F dash is equal to K 2Q1 Q2 upon R square, which is clearly, as can be seen, this portion is our original force F. So we get 2F. So what do we have? The new force due to this variation is twice the old force. What is the ratio? They can ask you the ratio. F dash upon F is equal to 2. So this is the possible variation when we make a change in the charge. We can double both the charges. We can make both the charges half. We can double one of it. We can keep it as it is or triple the other. Any variation. Your work is to just substitute the variation in the formula, because normally the student have this habit, charges are doubled, force will be doubled or force will be half. Don't do that. Just take the variation and substitute it in the original formula. Now let us consider another variation of the same formula with the change in R. Let us take a new distance. R dash is equal to original distance divided by 2. So let us find out the new force then. F dash is equal to K Q1 Q2 upon R dash. K is the same as before. Q1 and Q2 are same as before, but R dash, that is the distance, is changed. So let us substitute and see. Don't be in a hurry. Substitute and see. You have to substitute in the formula either on the paper or mentally. I have put this bracket because students tend to just fail to invert or find the reciprocal of the denominator or the numerator. That's why I have put the whole bracket, right? So now what is my answer here? K, Q1, Q2 upon r square by 4. So f dash is equal to 4 as making the reciprocal k q1 q2 divided by r square, where this again is f written here. So what is my answer? F dash is equal to 4f. So this is the new force provided the old arrangement is changed such that we have reduced the distance by half. Sometimes they may only say reduce the distance by half, or they just can give you the value. Now the distance is r by 2. Whatever it is, understand the language and substitute in the formula. You have no other way out. So students, again in this question, acha, distance is reduced half. Okay, then the force is doubled. Is the force doubled? No. The force is 4 times. The new force is 4 times the old force, because r dash is a square here. Clear? I hope I am clear with the variations. So we have made 3 variations. One, change in the medium such that the value of k is changed. Change in the charges value, and then change in the distance value. While studying itself, you keep in mind, when any formula is given, every variable can be changed. Okay? Okay. So now we can make our own numericals, we can make our own variations. So let us make a variation and try to define 1 Coulomb. Again, going back to the formula, F equal K Q1 Q2 upon R square. Let us consider 2 charges. Q1 is equal to 1 Coulomb, Q2 also equal to 1 Coulomb, kept at a distance of 1 meter away from each other. Medium of keeping the charges is air or vacuum. Substituting the formula with the values, we have F is equal to K 1 Coulomb multiplied by 1 Coulomb divided by 1 meter square. Okay, again putting 1 meter in brackets. So as you can see, we have the value of F is equal to K. So F is equal to, if the value is K, what is the value of K? Into C square, Coulomb square and meter square. Now remembering the value of K as 9 into 10 raised to 9 Newton meter square per Coulomb square, and this value or unit I will write here, Coulomb square per meter square. We can, this is the value of K and this is the unit which we got from this particular formula as I substituted 1 Coulomb and 1 Coulomb. So I cancel Coulomb square and Coulomb square, meter square and meter square. What am I left with? I am left with F is equal to 9 into 10 raised to 9 newtons. Now we define the Coulomb's law as if at all the charges exert a force of 9 into 10 raised to 9 newtons on each other by placing them 1 meter apart, then the 2 charges which we have considered is 1 Coulomb each. That is the definition of 1 Coulomb. I write the definition in parts. If the force between the 2 charges is 9 into 10 raised to 9 newtons calculated, and the distance between the 2 charges is 1 meter, then the charges Q1 and Q2, which we have considered, are said to be 1 Coulomb. That is the definition of 1 Coulomb.